Hello, everyone. Welcome to my presentation titled Embracing Clean Architecture in Spring with Kotlin. So I'm going to talk about clean architecture, but with a very short introduction to architecture and software engineering in general. And then we will end up with a demo in Kotlin using Spring Boot. So, a few words about myself before we start. I'm senior software engineer at OLX, and I'm Kotlin passionate. That means that I really enjoy programming in Kotlin. I've been programming in Kotlin on the server side for over 6 years right now, so yeah, I like it. And DDD enthusiast because in software engineering, I like this part of our job in which we try to solve the problems, which are not always technical ones, but very often it's the organizational one, and domain-driven design is a very good methodology to face it. If you'd like to catch me on some social media, feel free to do it. Especially if you'd like to check out my articles on Medium, I invite you to do this. Recently, I've posted about null safety. Not only about Kotlin null safety, but the idea behind it in general, and some kind of my opinion on that. So if you're interested, feel free to do it. And let's start the actual presentation. So, software architecture. This is an image generated by OpenAI. I asked him to show me what's software architecture. And this is it. This is some kind of organized blocks with some connections with each other. And we can say that this might be some kind of definition of software architecture, because we want to think about it as structurizing our code and setting up interfaces, etc. So yeah, this might be it. However, before we start the definition part, the architecture word is quite crucial, because you probably heard this analogy with civil engineering, and today there was already a presentation that this analogy was really highlighted by the speaker. So this is a blueprint. Sorry. Yeah. Right? This is a blueprint that architect in civil engineering is creating for people who will be involved in the construction. So it's kind of a plan how to do it. We also like to have plan at the beginning of the project. What's going to be built, what are the estimates, and having all the measures like here, we can do it. However, this metaphor, I think, doesn't fit well, because as we can, for example, replace a window, put a wall, it's very hard probably to replace the basement. And in many programming projects, that's the case. Sometimes we like to replace the basement because there's a pivot on the market. I don't know, there's a pandemic and we need to change the business model. So in our field, everything is changing, and this civil engineering metaphor, in my opinion, personally, doesn't fit very, very well. I like these two definitions about software architecture. First one by Martin Fowler, because at the beginning we can have a plan how to build it. We can even divide it into the teams, say, okay, these will be two very separated microservices. But when the times is clicking, when the clock is clicking and we face some problems, we make some decisions, and at the end, it's probably not the way we saw it at the very beginning. So architecture is actually the result of some decision we made in time. And I really like this one, and the other one, that architecture is about the important stuff, whatever it is. Because many projects has different ideas, different decisions should be postponed as far as it's possible. And in software architecture, architecture should somehow protect us from what we don't want to decide at the beginning. Let's say we don't want to choose database at the beginning for some reason, because there is some weird project that we don't want to do it. Then we pick such an architecture that helps us do it. And when we think about decisions in software architecture, there are stuff that drives us. There are architectural drivers, which can be grouped into 4 categories. So Functional requirements like what's going to be built, how our system is going to behave in the future, quality attributes like performance, maintainability, stuff like that. So what's the average response time? What's the accepted latency? Technical constraints like libraries we use, programming languages, but also experience of people you have in your team. Because probably you shouldn't use very complex architecture when you have only juniors on board. Business constraints like law regulations, like hard deadlines. I don't know, Black Friday might be hard deadline, right? So having all these drivers put together, written down somewhere, for example, using ADR, architectural decision record, you can actually make a decision if you know what influences it. So let's consider such an example of a system. So we have some base level of functionality, performance, maintainability, and readability, right? We've built something. Then the new requirement comes, and here it is. What it does is more functionality, of course, but we introduced some new entity, whatever we have underneath, and there is lower performance because some new method calculating something. And we already made some research. We can fix it. We can introduce another tool, another library. However, no one have ever used this library before, and we need some time to adopt it, to make the spike, to try it, and be sure that whatever it is, we can put it on production and not fail. So what we say to the business, we can do it. However, there was one case that the team experience is one constraint in this case, because we need to learn it. The other case is that business says, okay, but we have hard deadline, and it's really hard deadline, not some kind of imaginated deadline by the business people. And this way, we very often come to the ugly optimization. So we can do it, we can make the performance great again. However, the maintainability and readability lowers. And this is it. This is actually what architecture is very often about. It's about trade-offs. And it's very important to remember that our job is to deliver money to the business. It's not like we can infinitely learn new stuff and people would just pay for it, because that doesn't work this way. So it's trade-off. We can learn new stuff, but we also need to deliver the money. That's very important to understand. So when we have to make some decision, we need to have options. We need to know what's the toolbox, what can be chosen, etc. That's why we will go shortly through some architectural styles, going forward to finally know what the clean architecture is. So the very basic one, layered architecture, right? Everybody knows how it works because there are plenty tutorials over the internet. It's just simple. However, it has many cons. It's tightly coupled, right? Because the flow right here is always from the up toward down. And the case is that the business layer is always dependent of the persistence. That's something that many of us don't like, and there is a good reason for this. When the complexity becomes bigger in our application, then it's very hard to maintain an application like this. However, in some cases, layered architecture is good enough, and there's totally no reason to choose any sophisticated one that you've heard about on some conference, right? The very important stuff here is that the layered architecture is usually implemented having 3 layers. However, you can have as many layers as you want. Very good example of 2-layered architecture is when you have some projection over the database, and all you need to do is just simply get the data from the database, map it to DTO, and that's all. There's no business logic. So why should it be put through some artificial layer that does absolutely nothing? It's good enough to have 2 layers in this case. To fix disadvantages of layered architecture, we might want to choose onion architecture. So the idea here is that our application is domain-centric. Domain is the place of our application where we put all the crucial knowledge or everything that is core domain of our business, something that should be the best when it comes to the clean code, the best place in our application, right? And here we have entities, we have aggregates, we have domain services, etc. In application layer, we can have some use cases, we can have some other services that are commonly called application services, which are meant to solve the issue when we have more complex process that doesn't fit into the domain because it's operating on more than one simple part of a domain. It's just coordinating stuff between them. And presentation / infrastructure / whatever is dirty layer, which is very outside of the domain. The clue here is that when you take a look at these arrows, it's always coming into the domain. Domain doesn't know about application. Application doesn't know about presentation or infrastructure. That's the role of thumb here. And of course, it's highly testable. It's well separated. It's flexible because we can replace database. We can replace whatever we have at this outer layer. However, it's more complex. There is more boilerplate code. It's harder to start, so there is a learning curve. There is one more disadvantage here because in some cases, you want to make this dependency to some external source very, very visible. And in this way, when you have your domain code, it's not visible there because you're not explicitly dependent on something that comes from the external world. In this case, you might want to consider another architecture style. And there is one more, hexagonal, which, as you can see, pros and cons are constant, the same as for Onion architecture, because it's actually having same concept when it comes to the outcome of architecture. However, the initial idea is very different, because as you can see here, we have only, let's say, 2 layers. Of course, in Onion architecture, we can have more layers than just 3 I've showed on previous slide. The main idea here is this port and adapter pattern, which is basically what hexagonal architecture is about. I've seen many architectures that were called hexagonal. However, they were kind of a hybrid with another architecture styles, because the main idea here is that you have some core, you have some application that it's, let's say, pure, clean, whatever, and all the integration stuff is done on the adapter side. So basically, it's like 2 layers here, and there's no specific rule in this architectural style to have any additional layer. Of course, it can be there. However, the initial idea is that core application has some interfaces that are ports, and ports are implemented by adapters. This way, all the dirty code is here, right here, and here in this case. So the question then is, okay, so we have these architectures, they are quite cool. Why don't we simply use them? Because they seem clean. And what is clean architecture then? It's a book, right? You might have read it by Uncle Bob. And in this book, Uncle Bob is actually introducing a new idea that he called clean architecture, because what he found is that different architectural styles have something in common. And these features that should stand by clean architecture are shared between these architectural styles. That means that clean architecture is such an architecture that is highly testable. It's independent of framework, of graphic user interface, of database, and any external dependency. This is clean architecture. It doesn't need to be particularly Onion or hexagonal. There are different patterns there. And what Uncle Bob does in this book, he makes a point that when thinking about architecture, we might want to re-explore solid principles. on a different level of abstraction, because solid is good, everyone knows it, everyone knows how to implement it, what are these rules. However, they are not only on the level of classes, methods, that they can be put higher at the level of architecture. And that's what Uncle Bob does here. And this might be familiar to you because this is an image of how he wanted to present what clean architecture is. And the note here is that it's not like you need to stick to this, all these layers and you always need to have this structure. It doesn't work this way. He shows what it can be presented like, but the initial idea is what I've presented on the last slide. So architecture, clean architecture by Uncle Bob should be screaming architecture. What does it mean is simply explained by use cases. Because your architecture should scream to you, to developers, to your colleagues from the team, what this application does. And use cases are a very good example of implementation of this idea, because use case is simply a class that already says by its name what's going to be done. I don't know, add to the cart use case or something like this, right? And use case, as you can see here, in this graph, it should be, when we have entities, it would be domain in our example. Outside of this, in this application layer, we have use cases. So use cases are for these business processes which are more complex and can't be expressed simple by some entity method. And in my example, I'm going to use some kind of example of clean architecture. As I already told you, there's no one ultimate way of doing this. You can mix it. The only idea is to stay highly testable, independent of framework, etc. And this is how I think might work also for you. It worked for me in different projects. And you can try, to work on your own different opinion on that, of course, and on your own different implementation. That's up to you. So what we have here is kind of an onion architecture with this dependency inversion right here, because infrastructure will depend on application, not the other way. So having dependency inversion here as port adapter, that's the way to do it. And let's jump into the code example. So let's have a very simple application doing very simple stuff, adding product and listing the product. So this way we introduce two endpoints, post and get, right? And how I see it when it comes to the software architecture, because it's a very simple example. Right? We don't need to invent any fancy architectural style. Let's start with the simplest solution. So layered architecture, and I have 3 layers. You might say I could have 2 layers right now, but I said, okay, why not? Let's make it 3 layers. And this is it. This is how the application would look like. So I will show you in the code because I've checked out here. So what do we have is controller, right? Very simple with 2 endpoints. Then we have product service, no complicated logic here as well. As you can see, just adding product, getting products. And yeah, and here, of course, injected repository, which is JPA repository. And as you can see, my entity here is shared between model and JPA, because that's how people tend to do it. And let's stick with it. Let's start with it. I know I also don't like it, but it's the easiest way to do it right now. So product is both model when it comes to the business and when it comes to the JPA. And what else? What's going to happen next? Yeah, it was demo, right? Let's add some complexity. So we don't need only products, but also discounts. And the idea is to simply provide some easy way to add discount to products, but we don't want to create orders yet. That's not that phase of development that that product, that project, right? So there are two types of discounts, buying N for the price of one, which is very common in food delivery application, like buy 2 burgers in price of one, right? And the other one, discount, is count-based percentage, like, okay, I bought, I don't know, 100 CDs, so I've got 5% discount, something like this. So what can we do? We can have 2 endpoints. Both of them are post HTTP methods. The first one is obvious, adding discount to product, RESTful API, right? The other one might be a little bit annoying at the first sight because, okay, why calculating prices post method? Why isn't it get? Because we just need to get a price. However, I'd like to put a request body in this HTTP method. That's why I thought that it would be more restful to have it post method for calculating price. Because we don't have orders, we don't have cards, we will just have the request body with product ID, quantity, list. Yeah, so this is it. So how can we implement it at the level of architecture? So we already had product service. Right now we have discount service, right? That's obvious. So this is it. When we take a look at the whole architecture, it's still 3-layered, right? We have presentation, business, and persistence. And when we take a look, because right now it's demo time, yeah. When we take a look at the code, let me check out, because if I were to write down and live code every line, I probably wouldn't make it in time. Yeah, that's this one. So let's see the code. Let's start from the controller. As you can see, we have more endpoints because we have adding products, we had getting products, also adding discount, and calculating the price. This endpoint is actually the additional one. We don't need to take a look at this right now. I'm going through the code quite quickly. However, this code will be available. It's already available on the GitHub. I will share the QR code, so if you need to analyze line by line on your own pace, that's doable after the presentation, don't worry. But I'm going to focus mostly on the architecture level here. So this is our controller. When we take a look, we have 2 services, right, as I already told you. Product service didn't change, actually. And the discount service is added in this commit. We have very dirty method here with some kind of factory here. It will be refactored later. I've put it this way on purpose to show you that it can be as dirty as you can see. And we have additional, yeah, this one is not in our interest right now. However, yeah, we have calculating price for products in this discount service. It also has some kind of weird logic underneath. That's nothing we should worry about right now. But we have this product repository. It's still JP repository. It's still using the same model as you can see here on the left side of the slide. Of IDE, actually. We have product, which is still entity. It's still part of our business model. And as you can see here, we have this Hibernate mapping to the discount. Discount is an abstract class, so whoever says that there's no such thing as object-oriented to relational word mapping, it actually is, because we can have abstract class that is JP entity. We can have different implementation of this. So this is actually a very good example of how it shouldn't be done on production. However, let's explore it. So we have discount. It has 2 subclasses as it was required. All of them, both of them are implementing this calculate price method. And that's all. That's what I wanted to show you and to analyze what should be done to make this architecture clean. Because as you can see, sharing the model for both JPA and business classes is probably not the cleanest way to do it. Because right now, we aren't independent of frameworks and libraries, especially we aren't independent of JPA. So good practice is to take a look in your imports and see what do you import into your business classes. So the first thing I want to do to clean it is to fix the problem with sharing classes between JPA and business model. I have a good comment for this. As you can see here, the message, check out, it's extracting persistence as adapter. So basically, what we can do to make our business model be independent of JPA model is to introduce port and adapter pattern, stealing it from the hexagonal architecture. However, this is not a hexagonal yet. So let's take a look here. We have now port, which is an interface of product repository, and it's operating on product from model. So when we take a look at product in model package, we see that now it's a simple Kotlin class. There's nothing complex here. It has discounts, right? Discount is also clean Kotlin. We don't have anything imported that shouldn't be probably imported right here. And if you ask me, okay, so we have port, we have nice classes in Kotlin. So where's the implementation? The implementation, I've put it in adapter catalog, but later on it will be moved to have this catalogs cleaned up. But I wanted to make a point that we are using this architecture pattern. So it's an implementation of this interface, and we inject this external dependency, which is dirty, because we consider JPA as dirty dependency because it's from somewhere else. We have no control over it because we just import it in Gradle, Maven, whatever. So in this file, in this adapter, we have all the mapping to entity, right? From entity to model, etc. So all the dirty stuff, because in Hibernate, you probably know if you write code in Kotlin, you need to make some stuff nullable, or you should expect a null, even though you know that it shouldn't be possible. So keeping all that rules that makes your production code, your domain code dirty, you can just put it to the adapter, and you don't need to care about it in your domain code. So this is it. This is what we did. It's actually a very simple change, but it's a good point to start when you're refactoring toward clean architecture. So what can we do next? When we take a look in the service, because service right now should be also part of our domain. Sorry, because it's not showing very well here. So this is discount service. And as you can see, discount service has method, which takes product ID and some DTO. When we take a look in the imports, we import this DTO from the API layer. So that's something that you should already know, that it's not good, because we shouldn't be dependent from the layer above, because we like to make this architecture clean. So when we are inside domain, we shouldn't know about application, we shouldn't know about infrastructure, etc. So the next step would be to make this domain agnostic from any external dependency. And this is it. This is the next commit. Yeah. So right now we have discount service, which, as you can see, takes as an argument discount in this method, and the return type is also discount. When we take a look at the imports, in the imports section here, we see that discount is imported, it's from domain, right? That's okay. Anything that is imported not from our code right now is Spring and the Java util, but we're gonna fix it later. So this is it. We have discount service, we have product service, which became very short class right now. And because of pricing functionality that we wanted to add, I extracted it to additional service, because that's something that probably not discount service and neither the product service should care about, because it's some different stuff. It's just calculating something. It's not managing the discounts. It's neither managing products. So we have additional service. The next thing that I don't like here is this transactional. Because, okay, when you think about it right now, we don't have dependency to to the database. However, we have transactional. So some kind of, we have this dependency because transactional is opening a database transaction. So maybe not explicitly, but we are dependent on the database. So the next way, the next step to be done will be to make the domain actually framework agnostic. Because of having service here, we allow people to make this transactional annotation and many others that shouldn't be in our domain. So when we check out here, and I'll show you, yeah. So when we take a look here right now, we have domain, we have application, we have persistence as different part of our infrastructure layer. And in our domain, discount service right now doesn't have any import from framework, from Spring framework. It doesn't have this transactional. So you might ask, okay, so where did the transactional went? Because we know that if we don't have transactional, in some cases in Hibernate, we will end up with problems. Yeah, so knowing that, we need to somehow define beans when we don't have services as the annotation. We need to have somewhere the configuration of these beans. And this is the place. I've put it in application layer. However, if you think that application layer, because of presence of use cases, shouldn't know about the framework, you can always create additional layer that would be above application. This way you can make this application config somewhere above. However, you need to somewhere put the beans definition. And having these beans here, when we take a look lower, because still we don't have transactional here, when we take a look, yeah, here, at the implementation of our product repository, I've put transactional here. Because in my case, I don't have any complex process that requires atomic operation on many transactions, on many methods being invoked from the domain. This way, I can put this transactional here. However, I see, and I've seen very often use cases in which we need to have some kind of coordinator that makes sure that, I don't know, if we create a loan and we want to make a loan, we need to check some different stuff, and all this should be atomic, and nobody wants to do Saga because it's complicated. We prefer to put transactional over some method, right? So where can we do it? We can do it in application layer, or if you don't agree, you can create additional layer above, and it will be still correct. So what I introduced here as well is the use case. So this is part of application layer. We make this way our architecture screaming to us what's happening right now. It's a different approach to what you might have seen in many examples of projects like application services, which has plenty of methods, and there are God classes because they coordinate everything. Instead, you can have a list of use cases. It's much useful to see in one catalog what are all the use cases in our application. So here we have simple use case for calculating price. And that's it when it comes to the demo. When we take a look how this all application looks like now from the perspective of architecture, not only from the code, we can see some C4 model I've created for you. And maybe it doesn't look very onion or hexagonal at the very first sight. We can spot some parts of these layers that are available in our code. Presentation layer, because we have controller. Then we have persistence layer, because we have repository, right? There is an adapter which uses JPA repository. We have application layer because we have this use case we've introduced, and the rest is domain. And here, very important stuff is that any arrow that is crossing the line of domain should be inside the domain. And that's a very important rule when it comes to the clean architecture. The other rule is that when we are at the same level, so let's say we are in domain as here, when we would be product service, we shouldn't call another service at the same layer, because that's one of the rules of clean architecture introduced by Uncle Bob. Because we are just putting more spaghetti at the same level, and we are not trying to make an abstraction over some process that is obviously needs some kind of coordination at a higher level. So yeah, this is it. This is how the architecture looks like now. And at the end, yeah, because we are heading to the end, I wanted to show you some symptoms of unclean architecture. So first of all, when we have tight coupling, when you see the code that is spaghetti code, things are just connected with each other at many levels, at the same level, that's a sign that something is not well designed. When the code is hard to test, because the idea of this clean architecture is that all these use cases, domain, is easily testable using unit tests. You don't need to create, I don't know, populate a database for this, because you don't need integration tests done. You can test the logic using only unit testing, and mocking many stuff is also not necessarily needed there. Mixed concerns when we had this JPA class that was at the same time our business logic class, that's a symptom. When you have cycles, however, we didn't have in our example, but whenever you have that, something is wrong. Difficult to extend, which means that, let's say you have modular monolith, which is very popular recently, and you need to add some very basic feature somewhere, and for some reason your changes are in half of the modules, right? Something is wrong, maybe something is wrongly designed. When you have a bug fix and you're not sure where to put it, then your architecture is not screaming to you, because it should be obvious where this change go. So yeah, that's it. If you have any questions, I encourage you to do it right now. Here's the QR code for this GitHub repo. I've also put their slides. So if you're interested in going through the slides, it's in the presentation catalog in the root folder of repo. So you can scan it and do whatever you want. And yeah, are there any questions?